Today in this talk, we'll delve into understanding of how to create a secured environment for running your workloads that deals with the sensitive data. Yeah, so we'll try and understand how to create a secured environment for running your workloads that deals with the sensitive data, leveraging hardware-based encryption and attestation mechanisms. In particular, we'll see how to create a traditional VM in a secured enclave, thereby improving your overall cluster security. So hi, this is Rishika Kedia. I'm product owner for OpenShift on IBM Linux One systems from IBM. And I have my colleague Baswa, who's a senior software engineer with IBM, and we are going to talk about how to create a confidential VM in Kubevirt with hardware-based TEE. Kubevirt is a project that allows you to create and manage your virtual machines alongside of your containers on the Kubernetes clusters. So our agenda goes like this. We're going to explain the gaps, security gap that we have today with the traditional VM, which establishes us the need of having a confidential VM, and we'll go about showing you how to create a confidential VM with Kubevirt. So the current traditional VMs poses a lot of security risks in terms of securing and isolating and managing your data. So data encountered in computing itself exists in three states, right? We understand that data exists at rest, data in transit, and data in use. Data at rest is something that deals with data that is stored either in disks or in some cloud storage like your S3 storage. Data in transit is data that keeps moving around the devices or over the network. Data in use is that active data that is being used in your computer's memory or processor, right? And data security so far has been focusing a lot on safeguarding your data and safeguarding the data that is in either rest or in transit. Like we have this BitLocker facilities or Lux encryption, which focuses on the full disk encryption and thereby safeguarding your data at rest. All of these cryptographic measures like your TLS, SSL, focuses on safeguarding your data in transit. Data in use was kind of leftover. I won't say leftover, but there was a misconception that it was safe. Why? Because it was residing in that closed enclave or isolated environment of a physical server. But with the rise of the cloud computing, we understand that multiple tenants kind of share these compute resources. Hence, there's a lot of insider attack on your data with the aim of manipulating it, with the aim of stealing it as well. So, and there is a lot of regulatory compliance standards also now imposing this requirement, like GDPR, which says that you need to protect and the cloud service providers need to protect your data from being unauthorized, so that they are not accessed unauthorized. So the solution is that we are going to have a confidential computing. Confidential computing ensures that your VM is created in a secured enclave, which is provided by the hardware-based trusted execution environment. Thereby, we are going to close this gap of protecting your data in use. Over to Baswa.
Yeah, so what is a confidential virtual machine? So it's a secure type of virtual machine, and it uses a hardware-based memory encryption to protect your application data. And confidential VMs actually provides the data confidentiality, which means that no one will be able to access the data except owner of the VM. So confidential VM actually is based on the trusted execution environment. It is a secure area in the microprocessor where it will allow us only hardware-based isolated environment to run a sensitive workload. And so any code running outside the trusted execution environment will not have access to the data which is available. And there are other confidential, almost all the CPU platforms provides the secure executions. And if AMD and IBM Z are provide secure execution. And how we can able to create a confidential VM in the Kubevirt. So by default, it's not enabled. So you need to enable through the feature gates. Suppose if you want to create AMD-based secure virtual machine, you need to enable with the AMD encryption save. And while creating a VM, you need to mention the launch security. There you have to mention save for in case of AMD-based secure virtual machine. And before going to the demo, I just want to show how the traditional guest memory looks like in the host. So here you can see that essentially the guest memory completely belongs to the host. So here host will have full access to the guest memory, so that guest can able to read and write into the guest virtual machine data. So here you can able to determine this one. The host actually we are going to create a virtual machine, and then it's actually virtual machine memory is backed by the shared memory object file, where we are going to use the shared memory util binary to modify the guest memory. So here is a small demo. And here on the left side, we have a guest virtual machine. And we are looking whether it is a non-confidential VM. And we are looking for to see whether the SNP is enabled or not. So here we are using a dev memory tool to read the physical address location 0 There is no data is available. So we are going to write small data, and we are going to read this data from the host side. So here we see in the right side is a host. So host actually is a work launcher pod where we can able to, these are responsible for creating the virtual machine. So from the host side, I'm able to see the actual data has been read. So with this is the same data actually we return the guest. So this actually breaks the memory encryption of the traditional machine, traditional virtual machine. Now we'll see with the confidential virtual machine how we actually be able to do it. So in confidential virtual machine, we repeat the same process which we did it for the non-confidential VM. Here we see that SMP is enabled, which means that the whatever it's running inside the one is fully encrypted. Here we are seeing the data which has been it's been empty here, and we are writing the data at 0 location here, and we try to read the same data from the host side. Here we see that the data has been not modified, so which means that the virtual machine is completely running in a secure, isolated environment. Yeah. So actually, the confidential virtual machine actually protect the guest virtual machine memory from the host side. So it will enhance the protection. Yeah, that's it. Thank you.